right, ladies and gents, let's do a little bit more writing equations of quadratics. Why? Because we need to do so. And my voice is going to sound a little weird because my face is numb from getting a filling in my tooth. So I apologize in advance. All right, if you have not written these on a piece of paper in your notebook somewhere, please stop the recording, hit pause, write these things down. You need them. You need to have access to them because on the day of the test when things are timed, you do not have the time to go and find them. You need it to be easily accessible. All right, you've got standard form. What is important about standard form? Standard form, remember that point right there, that plus c, the reason we like standard form is that tells us the y-intercept without any work. We love the vertex form because this h and this k represent the vertex. There is no work I have to do. The vertex happens to be staring right at my face. Intercept or factored form, remember that tells you not just any intercept, that's telling you the x-intercepts. And that's are these values here, this p and this q. So p comma 0, q comma 0 represent our x-intercepts. So that's another beautiful thing about intercept form. And you'll notice that all three of these forms have the a in common. So if I'm rotating and switching around between standard form to vertex form to factored form, my value of a can stay the same. So keeping all of this in mind, we're going to take equations that are given to us in graphs and we're going to write them in vertex form and factored form. So let's get to it. So again, make sure you have this written down somewhere. All right, so vertex form. So in order to write an equation in vertex form, which I made sure I gave us the equation right here, our goal is to find the letter a, to find the value of h, and to find the value of k. Well, h and k should be staring right at us from the graph, and lo and behold, there it is. So I've got the ordered pair 5, 3. So that 5, 3, there's my vertex, and that's my h and my k. Now, I can see that this graph looks pretty skinny, and I know it's concave up. So I know a is going to be positive. That's definite. And it looks like a is going to be greater than 1. But I have to actually figure out the value of a. And the only way for me to figure out the value of a is to find another point on the graph. Now, I pulled these graphs from Delta Math, and Delta Math does not like to identify an actual other point. You have to find the other point. So I'm going to find a point right here that is a nice identifiable point. That happens to be 4, 7. And I'm going to use that point as a random point to help me find the value of a. So I have an xy value, I have an hk value, which means in this equation the only letter I don't have is a, which is cool. That's what I'm going to solve for. All right, f of x is y. Don't know a. X is going to be that 4 minus my h, which is 5, and then plus my k, which is 3. And right here, it just turns into solving an equation. Follow those order of operations. 4 minus 5 is -1. I'm going to square it. Squaring a -1 gives me a +1. We always put that in front of the a. It really does feel like I've got cotton in my mouth. I'm going to subtract 3 from both sides, and I get 4 equals 1a. You can divide by 1, but, dividing by 4 by 1 is just going to make a equal to 4. So now you've got your a value, you've got your hk value. You can write this equation in vertex form. F of x equals 4, x minus 5, don't forget the squared, plus 3. All right, let's do another example. I encourage you to take this example, press pause, try it on your own, and then come back and see if you're correct. That's the way these things work best. All right, let's find my vertex. There it is, -2, 5. There's my h and my k. I need another point on the graph. cool. Let's use, ooh, not that. Let's use this point right here, 0, 1. That can be my x and y. So I have an x, y, I have an hk, and of course the only letter I don't know is a. I can see from the graph we are concave down, so I know a is negative. I can't really tell if it's gotten wider. It's definitely not skinnier. So not quite sure about a value itself, but I definitely can conclude that it's negative. So let's play the game of substitution and make it work. F of x is 1, don't know a, x is 0, minus h, so minus a negative 2 makes that plus 2, plus 5. All right, order of operations, 0 plus 2 is 2. 2 squared is 4. Again, we always put our square value in front of our a. Subtract 5, subtract 5. And divide by 4. A is equal to negative 1. Okay, so yep, definitely not any wider than it used to be, but we can see again if a is negative, which we said it would be because we were concave down, so we're good to go. So my equation, f of x equals, here's my a value. Again, x minus negative 2 makes that plus, and plus 5. And there's your equation in vertex form. All right, one more in vertex form, and then we'll do intercept form. Again, I encourage you to pause the video, try it on your own, and then come back. All right, let's see here. I've got my vertex staring at me right here, negative 3, 1. That's my HK. I'll use the y-intercept of 0, negative 1 as my random xy that's on the graph. Now it's just a game of substitution. Replace the y value with negative 1. Replace the x value with 0. The h value minus negative 3 makes that plus 3. And that k value is just 1. So that becomes 3 squared plus 1. 3 squared happens to be 9. Put the 9 in front of my a. Subtract 1. Oh, and this one's going to be a weird one, which is okay. Divide by 9, because the delta math equations are a little strange themselves. And I like fractions better, but your delta math examples are in decimal value, so just be mindful of that you will be given decimal values. But again, I prefer this right there. We've got our a then, we've got our h and k. So I can write my equation. F of x equals negative 2/9, which confirms, I guess I should have looked at this. We are concave down, so we should have been negative. We definitely look wider, so our fraction should be less than 1. X minus that 3 becomes a positive, and plus 1. And again, I said delta math, you have multiple choice questions. These values, your a values, are going to be given to you as decimals versus fractions, so just be mindful. All right, let's take a look at intercept form. Again, intercept form involves you finding not just any intercept, but the x-intercepts. So again, they should be staring right at you at the graph, which should make things a lot easier to deal with. And I can see that right here. I've got negative 4, 0, and I've got negative 6, 0. That means this is my P, there is my Q. Now, I still need to figure out A. Again, we can look at the graph and see that A is definitely going to be negative. Not sure if it looks skinnier, it doesn't look wider, so it might be a number bigger than 1, or it might be negative 1. What's nice in here is if I can find the vertex, which is right here, that's at negative 5, 1, I can use this as my xy point. And it's the same process that we did before. So I'm going to replace what I have. My y value is 1 for my ordered pair. Don't know A. X, we're going to use the negative 5 from the vertex, minus the p value, which would be plus 6. And then that negative 5 minus the q value, hence plus 4. Order of operation says I'm going to do what's inside these parentheses first. That's going to give me negative 1. I will multiply. 1 times negative 1 is negative 1. And of course we divide by negative 1. And it's definitely not any skinnier or wider, just reflected. So my final answer would be f of x, your a value, x minus your p, which would be plus 6, x minus your q, which would be plus 4. And again, when you've got those parentheses, anything inside the parentheses is opposite. So these values should definitely be opposite of what's inside here. All right, you try the next one on your own. Again, pause the video, see if you can do it, and then come back and see if you're correct. All right, I can see my vertex, negative 8, 0. Not my vertex, sorry, my x-intercepts, negative 6, 0. I can see I'm concave down. I'm definitely skinnier, so I think this a value is going to be something bigger than 1 and negative. We'll find out. And I can see I can use this vertex point, and that's going to be negative 7, 3, and I'll use that as my xy. This can be p, this can be q, and it doesn't matter which one is p and which one is q. All right, so off we go to this function. We'll use the 3 value from the ordered pair. Don't know a. Negative 7 minus a negative 8 becomes positive 8. Negative 7 minus a negative 6 becomes plus 6. So then that becomes a positive 1. That becomes a negative 1. Multiply these two things together. Divide by negative 1. A equals negative 3. So yep, negative, so it flips, and it's definitely got skinnier, so A was definitely a whole number value. So I can write my final equation. F of x equals, here's my A value, x minus p, x minus q. And there is your equation in intercept form. And again, these problem sets too, if the value is a fraction, Delta Math will have it as a decimal. So just be aware of that and have Desmos open if you need to convert a fraction to a decimal. All right, good luck.